Well, we're going to talk in this series of videos about a system of equations. We're going to start by discussing systems of linear equations. But anytime we talk about a systems of equations, we're talking about multiple equations and whether or not they intersect or not. So here I have three possible solutions for a system of linear equations, meaning that I have equations that are dealing only with lines. You can see here that one type of solution for a system of linear equations is to have one solution. In other words, I've got two lines and they intersect at exactly one point. This gives me an ordered pair, and that ordered pair is the point at which these two lines intersect. We say that this system is consistent in that it has at least one solution, and that these two equations are both independent of each other. In other words, they're not the same line. Another type of solution you can encounter is no solution. Now, anytime I have no solution, you're basically talking about parallel lines. And that kind of makes sense because by definition, parallel lines are two lines or any set of lines that never intersect. And if a solution for systems has to deal with intersecting lines and parallel lines never intersect, then there is no solution. This is called an inconsistent system. In other words, there is no solution. But we do have two independent equations, meaning we have two separate lines. So the final type of solution we might encounter would be considered infinite solutions. This is where I have, in a sense, one line laying on top of another line. So if you picture, if I have one line sandwiched on top of this line right here, they are intersecting at all points along that line. So there are an infinite number of solutions. In reality, we have a consistent system. In other words, we have that at least one solution, but what they really are is the same line, just a different way of representing the equation. So when we think of systems of linear equations, we have one solution, no solution, and infinite solutions. Let's look at this example right here, and we want to determine whether or not an ordered pair is a solution to the system. Anytime you are asked to determine whether or not a number is a solution to an equation, what that really means is I'm just going to plug those numbers into the equation and see that the left equals the right. Now, when you do this for a system of equation, you have to plug this ordered pair into both equations. In other words, it has to satisfy not only one equation, but it also must make the second equation true as well. If it satisfies both equations, then it will be a solution to the system. So I have this equation here, and I want to know whether or not this ordered pair is a solution to that system. So we're just going to take the ordered pair and plug it into the first equation, which is given by x plus 2y equals 2. So this would look like 4 plus 2 times a negative 1 is equal to 2, because the 4 represents the x and the negative 1 represents the y. So if I simplify this, I get 4 minus 2 is equal to 2, and yes, 2 does equal to 2. So this ordered pair plugs into the first equation and it's a solution. Now let's plug it into the second set of the second equation in my system. So this looks like 4 minus 2 times a negative 1 is equal to 6. So 4 plus 2 is equal to 6, so 6 is equal to 6. And yes, it satisfies both equations, so the same ordered pair goes into and makes the left equal the right for both of these equations. So we would say yes, it is a solution to the system. So let's try that again with this ordered pair here. Same system we're looking at, but I want to know whether or not this ordered pair is a solution for them. So I'm going to take the x and the y, and I'm going to plug them into the equation there at the top. So this looks like negative 4 plus 2 times 3 is equal to 2. So this would be negative 4 plus 6 equals 2, which 2 does equal to 2. So that part works. Now what if I plug it into the second equation? So this is negative 4 minus 2 times 3 equals 6. So negative 4 minus 6. Negative 4 minus 6 equals 6. So that's got to be, let's change to do our integer addition, and that gives me -10, which does not equal 6. So this part fails. Although it was a solution to the first equation, in other words, it made the first equation true, that ordered pair did not make the second equation true. So this is not a solution. And that's how we determine whether or not an ordered pair is a solution to a set of systems that we are looking at. And again, you want to make sure that you remember that we have 3 possible solutions for my systems of equations.